Hello and good morning, everybody. I hope you are all doing well. Your health is good, everything is good. You are eating well, sleeping well, and I'm sure you are gaming as well. So let's do some few maths. Today, our lesson is short, not as usual. We will have few activities. Then tomorrow, we will have more activities with angles and circles. So we are still with the chapter 15. About central angles and inscribed angles. We have a special inscribed angle that we can see in our circles. If I have an inscribed angle that is measuring 90 degrees, as this one here that we see in the picture, then the endpoints here, which are for the intercepted arc, should be lying on the diameter of my circle, meaning that the line that is connecting these 2 points passes through the center of my circle. The inverse also is right. Whenever you have two endpoints which are lying on a diameter, meaning the line that connects them is passing through the center of my circle, then the corresponding inscribed angle should be 90 degrees. Alright, now let's add all what we have studied about the angles in circle to solve this problem. So we have an equilateral triangle inscribed in a circle. How does the relationship between measures of inscribed angles and intercepted arcs help to determine the measure of each angle? I know we already know that if I have an equilateral triangle, its angles are all equal and they are equal to 60 degrees. So how can I prove now, using the theorems we studied about circles, that these angles are 60 degrees? How? So look at the intercepted arcs here. So each intercept arc measures to what? Third of my total arc. The total arc is 360 degrees, right? So if in this arc, for example, is third of the total, so it is 360 divided by 3, which is 120 degrees. So the measure of one intercepted arc is 120. All of these arcs are equal. Alright? Now, since the arc measures as the double of the intercepted, and we learned that the measure of the arc is equal to the double of my inscribed angle. So if this is third of 360, which is 120, then half of it is 60. So this angle is 60 degrees. The same thing, so this is 120, and it is inscribed angle will be half of 120, which is 60. The same thing for this one, it should be 60 since its intercepted arc is also 120 degrees. Now let's do this activity together. In circle C, look, usually we call circles by their center, so the center here is C, so we call this circle C. The measure of the arc DE, where is DE? This one is 84 degrees. Now I want to find each measure. The first one is the angle DGE. What is the measure of the angle DGE? Now it's clear. We have, this is an inscribed angle, and this is its intercepted arc. Now the arc is 84, so the angle will be half of that, which is 84 divided by 2, and this is 42 degrees. So the angle DGE is 42 degrees. Now what about the angle EFD? EFD. Okay, someone can say the same thing. This is 84 for the intercepted arc, and this is an inscribed angle, so this will be half of 84 degrees, which is 42. Remember we mentioned something yesterday. We said that if we have many angles, more than 1, 2, 3, or 4, whatever, if they are sharing the same intercepted arc, then they are all equal. So without any further calculation, you can say directly, since the angle DFE has the same intercepted arc as DGE, so its measure will be equal to DGE. And DGE is already found 42, so this should be 42 without further calculation. Let's solve this example together. In this circle here, I have the measure of the arc AC, that is 116 degrees. I have the measure of the angle DAB here, which is 28 degrees. And I have the measure of the angle BAC, that is 70 degrees. And I wanted to find the measure of the arc BC, which is this one here, and the arc AD, which is this small arc around here. Let's start from BC. How can I find BC? So it is an intercepted arc, and its inscribed angle is CAB. Since I have CAB 70, so the intercepted arc measures to double as 70, which is 140 degrees. So the arc BC has a measure of 140 degrees by the inscribed angle theorem, of course. Now, what about AD? Well, there are many ways to find AD. One of the ways that I suggest is by subtraction and addition postulate that we have seen in the last session. So look at this whole arc from A to A. We said that is 360 degrees. Now, what is the arc AD? It is the total 360 degrees minus the measure of arc DB minus BC minus CA, right? Now, what is the measure of the arc DB? It's an intercepted arc, and its inscribed angle is DAB. Now I'm given that DAB is 28 degrees, so the arc DB measures to double, twice as 28, which is 56. So the measure of DB is 56 degrees by the inscribed angle theorem, of course. Now, what is BC? We've already found it, that is 140, and CA or AC is given as 160 degrees. Now, 316 minus the measure of DB plus the measure of BC plus the measure of CA gives me the measure of AD. Alright, now DB we found it 56, and BC we calculated it 140, and CA is given 116, so this subtraction operation gives me 48 degrees. So the measure of my arc AD is 48 degrees, and this is arc addition postulate and subtraction. Alright, let's finish up. Here you have a simple homework. You have a circle that has a center C, and I want you to find the measure of the angle MNP. MNP, that's the first angle, and the second angle is LMN. So please find these two angles. It's very easy homework. Apply the theorems that you have studied so far. You are given this arc LM to be 70 degrees, and you're given NP, that is 60 degrees. Alright guys, try this example and upload your answers on classroom.google.com. For those who did not join yet, please do by putting this class code. You will see my class there. upload a clear picture of your answer with your name in it. If you have any concerns, remarks regarding the class of today or other classes, please send your comments and your questions through the same platform. Alright guys, have a nice day and see you tomorrow.